Swayam Prabha. Digital India. Educated India.
Welcome to the video course on watershed management. In module number 3, in lecture number 9, today we will discuss about conjunctive use of water resources. So, some of the topics covered in this lecture include introduction to conjunctive use, groundwater, surface water, conjunctive use, necessity of conjunctive use, advantages and limitations of conjunctive use, then conjunctive management, conjunctive schemes and mechanisms and modeling, and finally, we will discuss a case study. Some of the important keywords in this lecture include surface water, groundwater, conjunctive use, stream aquifer, interactions. So, as we discussed in the last few lectures, so watershed based water plans and water management is very complex. So, we have to deal with the various hydrological processes, various other processes taking place within the watershed. So, as far as water availability is concerned, we can classify mainly into surface water and groundwater. So, some places say people use more surface water, and some places depending upon the availability people use more groundwater. So, in today's lecture we want to discuss say how we can optimally use this surface water and groundwater, so called in a conjunctive use of surface water and groundwater, so that we can have optimal utilization and better watershed management. So, as we discussed, the water management is a big problem, either say watershed base or river basin scale. So, due to the various reasons like growing population, growing economy and various ecological and other needs. And then of course, as we discussed in the previous lectures, there is the water is concerned, it is availability is almost constant amount of water in the water cycle. So, to meet this increasing demands for water due to the growing population, developmental activities, growing economy and other things. So, there is increasing competition for the scarce water which is available. So, say you can see that as we discussed, there is unequal distribution in time and space. So, as far as rainfall is concerned, say generally rain will be available about 4 to 5 months, and then space is concerned, it is say from one location to another location, drastic variation is there. So, due to all this reason, there will be always conflicts as far as the water use is concerned within a watershed or within a river basin scale. So, we have to see that the water available water is allocated in an appropriate scale, so that there is not many conflicts, and then if any conflicts are there, we have to resolve these conflicts in an amicable way. So, as far as water availability or water resource is concerned, we can classify the water availability into surface water and groundwater. So, always a question comes with say depending upon the availability, say whether we want to use only surface water or only groundwater. So, but in today's topic we want to see that how we can utilize both in a better way. So, as far as the water utilizations are concerned, either surface water or groundwater, the main issues are, so as we discussed, the precipitation and peak runoff the rivers only few months of the year. So, actually during those time when rainfall is there, then water utilization is very small. So, when demand is small, then the availability is plenty. And then water development problem, say like transferring water from high supply season to high demand season. So, you can see that say summer season there will be high demand, but then availability is less. So, we want to transfer the available water from high supply season to high demand season. And then solution to the problem like surface water storage. So, whether we need to go for small reservoirs or large reservoirs, or groundwater storage, whether we can go for aquifer recharge, and then how we can utilize this groundwater. Then say like this, there are number of issues as far as whether when we discuss whether we have to utilize the surface water or groundwater. So now let us consider the surface water availability, say surface water in rivers, lakes or reservoirs. So there are number of drawbacks, say as far as surface water is concerned, like huge evaporation losses will be there as far as surface water is concerned. So approximately say about 20% of the average annual runoff say we lose by in terms of evaporation. So more losses with a large open water area. So when the reservoir is a huge area, then we can see that there will be more evaporation. Then as far as surface water resource is concerned, like lakes or reservoirs, sedimentation is a major problem. So as we discussed in one of the lecture, soil erosion results always say due to heavy rainfall or various other reasons soil erosion takes place, and then the sediments will be carried by the flowing water to the lakes or reservoirs or to the river. So this soil erosion results in siltation in the surface reservoir, and then finally there will be reduction in the storage capacity. So that is another major issue as far as the surface water is concerned. And then like say number of environmental problems will be there, like if we are going to construct a large dam and then say the large area we have to utilize for reservoir. So then there will be, we have to displace the people, then a lot of land will be flooded. So these kinds of environmental impact, like undesirable for human health, flooding of inhabited or a good agricultural land. So this can be another major issue as far as surface water is concerned. And then as far as distribution is concerned from the surface water sources, like say reservoir, so we have to construct say a canal system say for say kilometers of length. So generally the construction of these canals and then its maintenance is a very costly affair. So distribution of water as far as surface water is concerned, say these are some of the issues, say like evaporation, sedimentation, environmental problems and distribution of water. And now if you consider the groundwater, then of course say generally we utilize the groundwater wherever it is available in that on a local scale or on a particular watershed scale, or say where we consider. But of course most of the time we need to pump the water available from the aquifer. So generally we should have power for that. And then also when the water aquifer level or water table goes say drastically down, then we need to use more power, and then there is the issue, other issues. Then also say if we want to recharge the aquifer, then we have to construct say if we are going for artificial recharge, we have to construct some artificial recharge structures, or we have to go for rainwater harvesting type of structures. So these are some of the important issues when we discuss whether we have to go for surface water or groundwater. So now say as far as surface water or groundwater questions comes, let us look into what are the advantages, what are the limitations, and what are the key issues as discussed by Keller and others in a report of International Water Management Institute. So if you consider the groundwater storage, then the advantages will be little evaporation loss, then ubiquitous distribution, so wherever we want we can get, then operational efficiency, available on demand, and we will have better quality water. So these are some of the advantages as far as groundwater is concerned. Then if you store surface water in small reservoirs, then ease of operation, responsive to rainfall. So even small rainfall will have sufficient water in these small reservoirs. Then multiple uses, say like irrigation or water supply or other multiple uses. Then this also serves as groundwater recharge. And then if you consider large dam reservoirs, then the advantages are there. Say we have large storage, there will be reliable yield, then we can carry over whatever the available to the scarce months or the other seasons. then low cost per meter cube water stored. Then of course multi-purpose we can go for, it is not only source for water, but hydroelectric power project, say production and other multi-purposes. Then flood control and hydropower, then groundwater recharge. So these are some of the advantages by considering either groundwater or small surface water sources or large dam reservoirs. Now some of the limitations, say if you consider the groundwater storage, like slow recharge rate, then groundwater contamination problem, cost of extraction, recoverable fraction. So like say for example, if you recharge say X quantity, then we may be able to say recover maybe 20% of 30% of that. Then say as far as small surface water sources are concerned, limitations include high evaporation rates, then relatively high unit cost, then absence of over year storage. So we cannot store so much of water for say for the use of summer season. Then large dam, some of the limitations include complexity of operations, then where it is to be located, we have to relocate the people, and then say the area we have to find out. Then high initial investments and time needed to plan and construct. So these are some of the limitations as far as groundwater or small surface source or large source surface source is concerned. So some of the key issues like groundwater is concerned, say it is declining water levels due to our use, rising water level in some regions, like management of say access and use as far as the groundwater usage is concerned. Then some places the groundwater salinization takes place, say the coastal aquifers especially, there will be saltwater intrusion problems. Then many locations groundwater pollution problems, and then small sources are concerned like sedimentation, then adequate design, dam safety, environmental impacts. So these are some of the key issues as far as small surface water sources. Then large surface water sources like social and environmental impact, say like say large area to be flooded, and then here say we have to resettle the people living in that area, then sedimentation issues, then dam safety. So these are some of the key issues when we consider the groundwater storage or small surface storage or large dam reservoirs. So now say let us come back to say whether to utilize surface water or groundwater. So we have already seen the advantages of each say surface water or groundwater, then limitations, and then what are the key issues as far as the say either use of surface water or groundwater. So now earlier times, say before 1950s, say there were not much understanding as far as the whether there is say interaction is taking place between surface water and groundwater. So before 1950s actually the surface water source and groundwater sources were dealt separately. So since this understanding of the interactions and related issues were very rare. So that way then say a lot of research studies showed that there is constant interaction between surface water and groundwater. Say for example, if this is a river, then say nearby aquifers will be recharged by the river when say especially in monsoon season, when say a good quantity of water will be flowing through the river. And similarly, when this in summer season, when the water in the river will be level will be going down, then what happens, the nearby from the nearby aquifer systems, water will be coming from the aquifer system to the river. So there is a constant interaction between surface water and groundwater. So we cannot separate surface water and groundwater and then do a study, but we have to see its interactions. So the hydraulic connection between the aquifer systems and surface water sources are very important. We have to consider say when we assess the available source of water, and then when we use the either surface water or groundwater, we have to see what will be the effect. Say if we are using the surface water only, then what will be the effect on groundwater, and when we are using only groundwater, what will be the effect on the surface water sources. So in this figure you can see that say if this is a channel, river channel, then here there is a this aquifer system, then there is a well here. So you can see that if we are say keep on pumping in this well, then say the water available not only in this aquifer, but then you can see that say the water will be say recharging through this river channel, and then say this water will be coming to the production well. So, similarly, as I mentioned, say if we are not utilizing the aquifer say water, then say, and if the river level is going down, then there will be reverse flow taking place from the aquifer system to the river channel. So, that way a lot of interaction takes place between the stream and aquifer, and that way we have to plan as far as the surface water and groundwater utilization is concerned. So, now let us come back to the topic on conjunctive use of surface water and groundwater. So, last few decades in most of the water resource plans, the say water resource planners always mention about the use of surface water and groundwater together, and then the term called conjunctive use came, and so we can define the conjunctive use as combined use of surface water resources and groundwater resources in a unified way to optimize the resource use, that means water use, and minimize the adverse effect of using a single source. So, like say we are optimizing the both use of surface water and groundwater, so that it minimize the adverse effects of either using surface water or groundwater. So, that way the conjunctive use say what we are doing is actively managing the aquifer system as an underground reservoir. So, the say aquifer system is acting as an underground reservoir. So, during wet years when more surface water is available, then what happens, surface water is stored underground, say there will be good recharge to the aquifer system. So, by recharging the aquifers with surplus surface water, and during dry years say or in summer season, so the stored water what is available in aquifer system, we can supplement or replace the diminished surface water supplies, so as we have seen in the previous slide. So, that way we can define the conjunctive use as judicious use of surface and groundwater, so that all the needs will be met in an optimal way, so that without affecting the either the surface water source or without affecting the groundwater source, or say without any adverse effect of either by use of one of the source. So, that is the way we can define the conjunctive use of surface water and the groundwater. So, now as far as conjunctive use is concerned, say you may ask why we have to go for conjunctive use. So, here some of the things are listed here. So, say so for example, so it is conjunctive use means conjunctive use of surface water and groundwater. So, surface water is concerned, say we can easily get it, so lower delivery we can have it, and low extraction cost. So, we can easily either pump or under gravity we can get. Then variability in supply, so there will be say variability as we discussed, say sometimes supply will be there surface water, so sometimes it may not be there. And then what can happen, water logging. So, a lot of say if the water is not utilized in an appropriate way, then water logging, the area will be say flooded with water, and then its related issues as far as the agriculture is concerned. And then groundwater is concerned, say why we are going for groundwater, say always it is a reliable supply, but only problem is it is expensive to pump, and in many locations there are the groundwater tables is going down. So, decline in groundwater table. And then as far as conjunctive use, what is conjunctive use? As I mentioned, it is operation of a groundwater basin in coordination with a surface water reservoir system. So, that way say we are operating surface water and groundwater, and then groundwater is concerned, we artificially recharge the basin during the years of above average precipitation. When sufficient surface water is there, we go for more artificial recharge, so that we can use it later. Then water can be withdrawn during the years of below average precipitation when surface water supplies are below normal. So, that is the answer why we are going for conjunctive use and what is conjunctive use. So, now within this perspective, say what are the necessities of conjunctive use. So, we are looking for say use of surface water and the groundwater. So, what are the necessities? So, these issues are listed here. So, like as we discussed, there is constant interaction between surface water and groundwater, like aquifer and say stream interaction as shown here. So, groundwater and surface water are closely linked. So, we have to see in a say conjunctive way of use. Then groundwater maintains the base flow of rivers, and water in rivers can infiltrate into the ground. So, so that way we cannot separate. An abstraction of surface water and groundwater cannot be planned in isolation. So, as we discussed, there is interaction between aquifer and stream, so or river. So, once say when we are in say extracting water from aquifer, the other source will be affected, or when we are over extracting surface water, there will be effect on the groundwater. So, one will affect the other. So, example, abstraction of groundwater can reduce base flow contribution to rivers by lowering the water table. So, this that is why we have to go for conjunctive use. Then if carefully planned, however, the conjunctive use of rivers and groundwater can even out the seasonal variations in river flow. So, as I mentioned, whenever say more water, surface water is available, we can go for say surface water, and then also we can go for the recharging of the aquifer system. And in the summer, when the river flow is low, water moves from the aquifer into the river, so that more water can be drawn from the rivers, especially on the downstream side. Say on the upstream side, if the aquifer is recharging, then downstream side the river will be getting more water. And then rainy season, water flows from river to aquifer. So, when the head is rising, say water goes from river to aquifer. And then pumping from wells also intercepts some of the natural base flow to the river. So, due to all these issues, say we have to go for conjunctive use. So, that is say the best way of utilization of the available water resource. Now, say we can say, even though say most of the time say we say either we go for surface water or groundwater conjunctive use. So, why we are advocating the conjunctive use? So, there are number of advantages. The limitations are very few, but advantages are many. So, some of the advantages I have listed here in this slide. So, the conjunctive use, say through conjunctive use we can exploit storage capacity of an aquifer, and there is ease of transport of water by a river or channel. So, especially in summer season, when the say upstream locations, say if the aquifer is giving water to the river, so that water will be available on the downstream side. Then aquifer is used to store surface water when there is an excess of it, and it would otherwise be wasted, say in the winter or during the monsoon season. So, that is another advantage. Then a river is used to transport water from the aquifer to where it is needed when river discharge is too low on its own, as often happens in summer. So, summer season, say the water from the aquifers will be going to the river system, and especially on downstream side this water will be available as far as the river is concerned. Then conjunctive use can reduce abstraction from rivers when discharge is low by using the groundwater instead. So, there we can see that from the rivers, when the say we can reduce the abstraction, so by using the groundwater. Then problems of waterlogging, groundwater overuse we can reduce. So, in an optimal way, when we plan surface water and groundwater, waterlogging can be drastically reduced, then salinization can be reduced, then say the salinity introduction can be reduced. So, and also the groundwater overuse can be reduced. So, that way finally the advantage finally what I can say is that say this is the conjunctive use is the best way of sustainable water management as far as any watershed or a river basin is concerned. So, these are some of the advantages as far as conjunctive use is concerned. So, now as I mentioned, only few limitations are there. So, some of the limitations I have listed here. So, there is increased energy consumption for pumping from wells. For example, if surface water is available in plenty and still if you are going for groundwater, then we have to use energy for pumping. So, that can be say mentioned as one of the limitation. So depending upon say if there is reduction in pumping efficiency, then large fluctuation of water levels, all this can happen. Then appropriate managed plans to be developed. So for the given watershed or given river basin, we have to appropriately plan whether we use this much percentage of surface water or this much percentage of groundwater, so that optimal use will be there. Then construction of appropriate groundwater recharge structures. So as we discussed, so during monsoon season, say we have to increase the recharge through artificial recharge structures. So that way we have to construct appropriate groundwater recharge structures, its cost is to be covered. Then administrative difficulties in defining acceptable and equitable groundwater rates when surface water is available. So if you are going for conjunctive use for on a watershed scale, on a river basin scale, so we have to define, okay, this much percentage should be from surface water, this much percentage should be from the groundwater. So so we have to assess all these and then we have to come up with appropriate conjunctive use plans. So due to that there can be some administrative difficulties. And then say one of the major problem in say in advocating the conjunctive use is people apathy. So especially farmers, if surface water is available, they will never bother to go for groundwater, since of course pumping is required, and then say they will prefer to use the surface water. So we have to educate the people, we have to give sufficient information that why we have to go for conjunctive use, what are the advantages conjunctive use. So that way we say none of these conjunctive use projects will not be successful without appropriate people participation. So people participation is very essential as far as the development of a conjunctive use plan for a watershed or for a river basin scale. So now based upon this discussion, let us see what are the important challenges as far as conjunctive use is concerned. So some of these issues are listed here. So like isolated use of surface water, ignoring optimal groundwater use in irrigation command may result into various environmental problems. So we have to go for an appropriate plan as far as conjunctive use is concerned. Then storage of excess surface water underground in an aquifer, say called managed aquifer recharge. So this makes most of the excess water by directing it into the groundwater. So we have to develop appropriate system as far as the recharge is concerned. So this managed aquifer recharge is not a simple process. So it is very difficult to do on a useful scale, since artificial recharge depends upon many factors like type of soil, type of aquifer system, type of say artificial structures which we develop. Then also this involves transferring water from surface to underground. So by dispersing it over the surface to increase infiltration or through aquifer injection wells. So we need to develop appropriate system for this. Then surface dispersal involves diverting water into an unlined canal or shallow lagoon in permeable sediments or rocks, so that water can percolate downward into the aquifer system. So we need to have a say appropriate system, say like unlined canal or say basin or lagoon, where through which we can say go for artificial recharge, so that more water will be recharged to the aquifer system, and then that will be available for further use. So it works best in areas with highly permeable soils. So as I mentioned, geology is one of the important factor as far as the artificial recharge is concerned. So wherever highly permeable soil is there, then it is easy to recharge the water. So especially in unconfined aquifers. But say confined aquifer, again recharge is not so easy. We have to identify where is the recharge area for the confined aquifer system, and or we have to go for through infiltration, say this deep wells for recharging of the confined aquifer system. So these are some of the important challenges as far as the conjunctive use of surface water and groundwater is concerned. So now say with respect to this conjunctive use, so we can now say define what is conjunctive management. So conjunctive management, say as we discussed, the conjunctive management is coordinated use of available surface water and groundwater supplies to meet water demands and increase water supply reliability. So, this is actually when we are developing some management plan, so that water availability will be there throughout the time, and then there will be optimal use and optimal demand management. Then the conjunctive management is a concept of conjunctive water management. It consists of conjunctive water management consists of maximizing the use of surface water during the time supply is plentiful and saving groundwater for the periods when surface water supplies are short. So, this is the essence of conjunctive management. So, in this we have to develop conjunctive management plans. So, as I mentioned, depending upon the watershed or depending upon the river basin, we have to consider various issues and then develop appropriate conjunctive management plan. So, the conjunctive management plan development include consideration of surface water and groundwater hydrology. So, we have to see the rainfall pattern, we have to see the geological characteristics, hydrogeological pattern, then water demand characteristics. So, how much water is needed, for what purpose water is needed, and when it is needed, whether say what season farmers need more water. Then water quality. So, water quality is very important. So, if the polluted water is recharged to the aquifer system, then the aquifer system will be contaminated. So, we have to be very careful in the artificial recharge, and then surface and underground storage capacities we have to see. Then conveyance capacity as far as either through the river or channel is concerned or canal system is concerned, we have to see. Then how much capital is available to invest as far as the conjunctive management for either on a watershed basis or on a say river basin scale. And then of course, say once the plan is developed, how we can implement it, and then how we can say operate it, and then how we can maintain it. So, all this include say the cost also very important, how much we can invest, and then how we can say retrieve some of the cost, and then how we can effectively operate it and manage it or maintain it. So, now in any of this conjunctive management, say we set the objectives according to the necessity of the particular watershed or particular say river basin which we consider. So, some of the important objectives as far as conjunctive management are listed here, say like evaluation of water resources. So, we have to evaluate, we have to quantify the surface and groundwater in space and time, that means variation with the location and then variation with the time to determine the water balance. So, we can first determine the water balance and then develop an appropriate conjunctive management plan. Then identification of critical areas of water logging and soil salinity. So, if already a watershed or a river basin is already affected by water logging, then we have to assess that area, and then we have to go for management plans for that. Then matching the demands of various sectors with available water resource and evolve strategy to meet demand of the future. So, we have to make appropriate plans so that the present demand and then future demands can be met using the conjunctive management plans. Then most of the time, say as far as even the surface water is concerned, we can estimate the availability, but groundwater is concerned, it is very difficult to estimate how much water is available. So, that way we have to go for mathematical modeling. So, through mathematical modeling we can simulate the various situations, various scenarios. So, mathematical modeling to simulate hydrogeological situations, generation of various scenarios, and then we can go for optimum development plans. So, mathematical model has an important role in conjunctive management plans. Then to evolve plan for controlling problems of rising water levels by adopting technique of conjunctive use and drainage. So, wherever the water logging problem is there, we have to develop appropriate drainage system, so that water logging can be reduced. Then to prepare sector or block wise plans for development of groundwater resource in conjunction with surface water based on mathematical model results. So, that can be another objective. Then to test sustainability of present irrigation pattern. So, what is existing irrigation pattern, so whether it is sustainable, and then whether if we go for conjunctive use, say that will improve the situation, and so based upon all this we can say whether we can improve the future water availability. Then to evaluate the economic aspect of groundwater development plans, say when we develop the plans for the conjunctive use. So, we have to see the economical aspects. So, whatever we are investing, whether we will get it back through the benefits. So, most of the time we can conduct a cost benefit analysis, and then say when the benefit is more than the cost. So, that way we can see that whether the project will be viable, even though it may be taking many years for that, but we have to assess, we have to do an economic analysis to see whether the conjunctive management plans are giving say appropriate results. So, then say as far as conjunctive use is concerned, we can go for different schemes. So, it can be, so it is optimal use of surface water and groundwater. So, as far as surface water availability is concerned, so we can directly use from the river, lakes or the reservoirs. Then groundwater is concerned, we have to pump from the appropriate using dug wells or the tube wells depending upon the location and availability. So, as far as when we develop plans or schemes for conjunctive use, say our main aim is, say whenever more water is available, we want to recharge that surplus into the underground or to the aquifer system. So, in most of the conjunctive use plans, the thrust is for artificial or aquifer recharge. So, how much we can recharge, so that we can utilize whenever scarcity is there. So, that is the basic principle as far as the conjunctive use is concerned. So, that way say in any of the important schemes of conjunctive use, the major thrust will be on aquifer recharge. So, like basin recharge, injection wells. So, we use this for when no suitable land for a recharge basin or with a confined aquifer system. So, we can go for basin recharge or injection wells. Then aquifer storage and recovery schemes. So, say whether we can use the same boreholes to inject and recover water. So, just like we can use a term called water banking. So, through the same well, say when surplus water is available, we inject to the aquifer systems, and then when scarcity is there during summer season, we can pump back the water in that aquifer system through the same borehole. So, that is so called water banking. Then say especially in most of the watershed, say the storm runoff, whether we can effectively utilize it for recharging the aquifer systems. So, through natural recharge, improve the natural recharge, or we can go for the artificial recharge structures. So, then also depending upon the area, whether we can use the sewage effluent, say especially the effluent is good quality after the various treatment processes. If it can be used for recharge, then many locations we use, especially in semi-arid and arid regions, we can utilize the sewage effluent for recharging. And while recharging this, when this say treated water goes through the aquifer system, then also lot of water quality will be improved through various processes like biological activities and then filtration, etc. And then another type of conjunctive use is the use of groundwater to increase the flow of a river, so called river augmentation. So, as I mentioned, so if the aquifer is recharging back to the river on upstream side, so that more water will be available on the downstream side of the river. So, that is so called river augmentation. The advantage is that river can be used to convey groundwater to its destination, like on the lower regions. Then say the effect is similar to what river regulation, except what water is stored in underground instead of the surface reservoir. So, surface reservoir directly we utilize for say either through canal system or pipe system. So, but in say wherever we say called river augmentation, we directly through gravity the water will be coming back to the river from the upstream sides from the aquifer system to the downstream of the river system. So, these are some of the schemes as far as conjunctive use plants are concerned. So, now as I already mentioned that say recharging is one of the important aspect as far as the conjunctive use is concerned. So, other than improving the natural recharge which is possible when rainfall or when the precipitation takes place. So, we can also go for artificial recharge structures. So, number of techniques are there as far as recharge is concerned. So, like some of the important techniques are listed here. So, like direct surface techniques like flooding, basins or percolation tanks, stream augmentation, ditch and furrow system, over irrigation. Then direct subsurface techniques like injection wells or recharge wells, recharge pits and shafts, dug well recharge, borehole flooding, natural opening, cavity fillings, etc. And combination of surface and subsurface techniques like a basin or percolation tanks with the pit shaft or wells. Then indirect techniques like induced recharge from surface water source, then aquifer modification. So, these are some of the artificial recharge techniques which we can utilize to improve the percolation or to the recharge to the aquifer system, so that we can utilize when surplus surface water is there. So, that can be recharged to the aquifer system and that can be used later when scarcity is there. So, this we will be discussing more about this artificial recharge techniques in later lectures. So, we will be having detailed discussion about artificial recharge techniques later. So, now as far as as we discussed earlier, the water use is mainly in the irrigation sector. So, most of the time if we can utilize the conjunctive use as far as the irrigation is concerned, that is our main thrust. So, how we can use the conjunctive use as far as irrigation development is concerned. So, some of the important issues are listed here as far as irrigation development is concerned. So, conjunctive use of surface and water and groundwater, we can use in irrigation development. So, that the use of groundwater helps cope with the peak demands for irrigation and hence reduce size of canals and consequently construction costs as far as surface water utilization is concerned. Then we can go for supplemental supplies from groundwater to ensure proper irrigation scheduling. Even if rainfall fails or it is delayed, so especially in rain-fed agriculture area, we can go for the groundwater supply compared to small check dams or reservoirs. So, that way we can improve we can go for proper irrigation schedule by conjunctive use. Then groundwater withdrawals lower the water table, thus reducing the risk of water logging, soil salinization and a consequent wastage of water for leaching the soils. So, we can see that lot of agricultural land become wasteland due to the water logging and salinity problem. So, if you use the groundwater on an appropriate way, then as far as water use is concerned, then we can recover this waterlogged or wasteland through appropriate managerial measures, including the using more groundwater and then developing appropriate drainage patterns. Then surface and subsurface outflows are minimized, causing reduction in peak runoff. So, we can use we can reduce the peak flow as far as surface flow is concerned, so that the flooding problems can be reduced. Then like that we can improve the total water utilization. Then when conjunctive use is integrated with artificial recharge, need for lining of canals can be reduced. So, depending upon the area, we can if the whatever water is seep through the canal system, that can be considered as it will be going through the aquifer system. So, that is recharging the system. So, that way the lining cost can be reduced. Then conjunctive use allows utilization of saline or brackish ground or surface water resources. So, by mixing with the fresh water or by alternative resources for irrigation. So, sometimes if the saline water is there or brackish water is there from groundwater or surface water, we can mix it and utilize in an appropriate way for irrigation development. So, that way conjunctive use will be more appropriate as far as irrigation development is concerned. So, now we can say while developing a conjunctive use plan, so we have to see various issues, we have to develop a management plan as far as the particular watershed or particular river basin is concerned. So, what are the important issues? So, we have to see the various issues what are listed here. So, like we have to develop local partnership. So, as far as the people on that village or watershed, we have to come you take their help, and through them only these various schemes to be developed. So, we have to develop local partnership, and then we have to assess the basin. So, we have to see what surface water availability, groundwater availability, and then how much is the demand. Then we have to collect various data like hydrogeological aspects, then the soil related aspects, then hydrological data. So, all those things we have to collect, and then we have to develop appropriate models, as I mentioned, modeling analysis to be done to develop appropriate plans. And then depending upon the plans whatever we develop, we have to evaluate each of these plans and then see which gives the most optimal benefit cost ratio, so that we can take care of the best plan. Then say we can develop a pilot project, so that the other people in that area will be attracted to that. So, pilot project can be done either district level or state level, so that other people will be attracted to this kinds of project. And then we have to develop a detailed feasibility plan or feasibility study for the area to develop appropriate conjunctive use plan. And then next stage is we have to implement the best developed plan, and then we have to constantly monitor whether that is working perfectly fine, and then whether it is giving the optimal outputs. So, that way most of the time we need to go for modeling. So, like groundwater hydraulic management models which incorporates hydrological model and groundwater simulation models, and various constraints in the management model can be efficiently used in the planning of the conjunctive use of water. So, we have to go for mathematical modeling and development of especially simulation and optimization models for appropriate development plans for conjunctive use as far as the area is concerned. So, now let us see what are the important mechanisms through which we can adopt conjunctive water use. So, some of the mechanisms I have listed here, like we can develop mathematical models for conjunctive use by considering the simulation as far as the hydrological aspects, groundwater aspects. Then we can go for optimizations, so that we can meet the demand and supply, and so that there will be optimal use. So, we can develop an appropriate mechanism through mathematical model as far as the conjunctive use is concerned. Then we can tackle problem of rise in water level, so that water logging problem can be reduced. So, this will be through use of groundwater or development of appropriate drainage plans. Then we can tackle the salinity problems, depending upon the area, then reschedule the operation of canals, so that appropriate mechanism can be developed. Then manage crop water requirement, proposed surface and groundwater use pattern in depending upon the location, I mean in space and in time. So, we can develop appropriate management plans. So, finally, in all this what we can do conjunctive use is demand and supply management, so that sustainable development or sustainable management is possible. So that development of suitable surface storage schemes, either small scale or large scale, then development of suitable groundwater recharge schemes, so that surplus water available in the monsoon season, rainy season can be utilized for artificial recharge. now let us see as far as conjunctive use is concerned, what are the major concerns when we go for conjunctive use, and then what are its solutions. Say for example, say as far as say surface water or groundwater is concerned, there is heightened competition for withdrawals depending upon the area watershed say between the stakeholders. So that the solution will be, we can formulate permitting programs and establish appropriate regulatory agencies and water user groups and say that kind of mechanism, so that the problems can be reduced. Then increasing in-stream flow regulations, say we can go for formulate the overall goal of permitting systems we can develop. Then compelling groundwater quality issues, so groundwater quality we have to keep, so that we can go for protection of surface and groundwater bodies. Then environmental concerns, so we can say develop various plans and then say assess those plans through mathematical techniques. We can find out appropriate plans and then implement it and then find the appropriate measures. Then say as we discussed, always modeling helps in conjunctive management. So if we consider surface water is concerned, we can go for surface water simulation using hydrologic modeling, then simulation of interrelationships among various hydrological processes. We can go for distributed or lumped models in space and time. Say for example, available models like MAGSHI or other models we can utilize. Then groundwater is concerned, we have to assess the groundwater availability, quantity, and then also the quality issues also we have to deal. So groundwater flow, stream aquifer interactions, we can go for distributed models in space and time. Say like model like mode flow will be very useful. So even mode flow can take care with respect to the interaction of surface water and groundwater also. Then say as far as optimal use is concerned, optimization model like optimal surface and groundwater allocation, then simulation optimization models, say like optimization model like linear programming, dynamic programming, then evolutionary algorithms like genetic algorithm, particle sum optimization, like that we can utilize the AI techniques also as far as optimization is concerned. So then we can integrate both the simulation and optimization models, so that we can have better modeling tools as far as the conjunctive management is concerned. So now say as far as India is concerned, conjunctive water use, say there are a number of projects have been implemented at various locations, and Central Groundwater Board and Central Water Commission are monitoring these projects, and a lot of fundings are also given for this type of projects. So some of the important projects I have listed here. So these projects details are available in the Central Groundwater Board website. So like Indira Gandhi Nahar Pariyojana project, then Sarda Sahayak irrigation projects in UP, Tungabhadra Canal Command area, then Kadaprabha Canal Command area, Hirakud Canal Command area. So like that number of projects are listed under the conjunctive water use plans, and these details are available in the Central Groundwater Board website. So before closing today's lecture, so let us briefly look into one case study as reported by in the website of Central Groundwater Board and reported by Raul and others in their paper. So the case study on conjunctive use is the Hirakud Canal Command area in Orissa, covering an area of approximately 2540 square kilometer. So you can see that this is Orissa state and this is the catchment area, and the total length of canal network is about 3500 kilometer. So this area is concerned, average slope is 1 to 6%, and surface drainage say mainly the Mahanadi and its tributaries, the river network. Then mean annual rainfall in the area is approximately 1245 millimeter, and most of these rainfalls are obtained during June to October monsoon season. Then say the depth to water level is concerned in most of this area, during pre-monsoon the water below ground water say is pre-monsoon, it varies from location to location 0.8 to 9.7 meter. Post monsoon it varies from 0.3 to 4.03 meter. and during monsoon the water level rises. So, below ground level it is varying from 0 to 2 meter during monsoon season. So, that way say larger area is waterlogged, especially in monsoon season. So, as far as availability and demand is concerned, utilizable groundwater resource is about 508 million cubic meter in Kharif season, I mean during say the rainy season, then 764 million cubic meter in Rabi season, I mean in say after the rainfall during the summer season. So, availability of surface water is 1360 million cubic meter and 1498 million cubic meter during Rabi season, and annual water demand is say about say 2025. So, and then other demands like say 50 million cubic meter for domestic, then 261 million cubic meter for industrial. So, by 2025 this will say the demand increases. So, some of the problems in this study area is waterlogging as per 1994 statistics. Post monsoon about say 1400 or 1500 square kilometer say waterlogging problems are reported, and pre monsoon 174 square kilometer reported. Some of the causes include topography setup, say less slope in the area, unlined canal systems, over irrigation, then predominantly paddy cultivation in this area. So, these are the some of the causes as far as problems in this area is concerned, like waterlogging and salinization. Then conjunctive use detailed plans were made. So, various possible conjunctive use strategies have been tested with the groundwater simulation model in the area. A model has been developed by the authorities. Then demand for irrigation Kharif and Rabi can be met from surface water. About 90% of the demand can be met from the surface water, and groundwater about 10%. So, this is one of the optimal plan. Then surface water irrigation cheaper in this, say this since water is readily available, maximum use of available surface water in conjunction with the groundwater to get maximum return. So, that is some of these plans were developed, and development of groundwater as say as the development, a large number of duct wells were proposed, say more than 17,500 duct wells were proposed. And then the study showed that waterlogging reduced with the increasing use of groundwater. So, for this huge capital investment is needed. So, about 950 million rupees required for this additional investment as far as the conjunctive use plan is concerned. And but of course, once this is invested, then within few years time the benefit cost ratio say worked out to be more than 1.6. Some of the important lessons learned from this case study include say during monsoon majority of the command remains waterlogged, and it is required that groundwater withdrawal during the non-monsoon period be increased, so that groundwater reservoir will have sufficient capacity to accommodate the monsoon recharge. So, whatever the water is available, say more water available during monsoon season, so that we want to recharge. So, that way recharge plans were made for this case study. Then during non-monsoon period there is a no danger of water logging, but still there is lot of scope for groundwater development. So, as I mentioned, say as per the optimal plans 90% should be utilized from the surface water and 10% from the groundwater. So, a lot of scope is there to say for groundwater development. Then increasing storage through combination of groundwater and large and small surface water facilities. So, that is say more say recharging for the aquifer system. Then judicious allocation of the water. So, that is one of the plan which we have seen 90% say from the surface water and 10% from the groundwater, and then area wise also we have to see judicious allocation. Then vigilant monitoring to avoid over irrigation. Then creating public awareness, that is very important in this kinds of conjunctive use project. Then necessity of public participation. So, the farmers should participate in the say the project. So, otherwise we cannot achieve the optimal plans as far as the conjunctive use is concerned. So, some of the important references used in today's lecture are listed here related to the conjunctive use. Then say before closing, say some tutorial questions, assignment and self evaluation questions are here. So, the tutorial question illustrate the conjunctive use of surface and groundwater with a case study. So, as I mentioned, this website of Central Groundwater Board's number of case studies are listed. So, you can go through it and develop a case study for conjunctive use. So, in the case study you can identify the problems of using surface water only or groundwater only, then study the demands for the area which is we are looking as a case study, then illustrate how conjunctive use can be used to solve the problems for the area. Then say you can discuss what are the lessons learned as far as that area is concerned. Then few self evaluation questions, discuss the issues related to our use of surface water and groundwater, what is the necessity of conjunctive use, discuss advantages and limitations of conjunctive water use, then illustrate groundwater recharge techniques within the perspective of conjunctive water management. So, most of these issues related issues we have discussed in today's lecture. Then a few assignment questions, discuss stream aquifer interactions and importance in conjunctive use, describe conjunctive management of surface water and groundwater with various challenges, discuss conjunctive use plan and mechanisms, how to develop conjunctive management model for a watershed. So, related topics also we have discussed in today's lecture. So, finally, just like an unsolved problem. So, for your watershed area, say you can prepare a master plan for conjunctive use by considering the surface water and groundwater. So, you can assess for that particular area by considering the irrigation demand and then other demand, say what is the demand is there and how much is the supply from various sources like surface water sources or groundwater sources, and then say you can develop an appropriate model say by considering the groundwater and say surface water. So, you can conduct detailed studies and develop an appropriate plan, an integrated approach for surface and groundwater by using the mathematical modeling. Then say you can look into the various options for groundwater recharge for the particular area is concerned. So, say this you can try for your watershed area. So, now with this today's lecture is over. So, further we will discuss the rainwater harvesting and rooftop water harvesting in the coming lectures in this module. Thank you.